Hello student, I hope you all are doing good. In this video, I am going to discuss about the chapter light. As you know, in our daily life, various phenomena like dispersion, reflection, refraction based upon the light. In this video, I am going to discuss about reflection. First of all, what is light? Light is a form of energy which help us to see various objects. When light fall on the object, it reflect the light, and when reflected light reaches our eyes, then we see the object. Next is light travel in the straight line. The common phenomena of light are formation of shadows, formation of images by mirrors and lenses, bending of light by medium, twinkling of star, formation of rainbow, etc. You can see in this picture, first phenomena, this is called reflection. This is on the basis of refraction. Apparent, we appear the apparent length of we can see the apparent length of the any pencils or any tubes. This is the rainbow due to refraction, and this is dispersion, which is all the phenomena basis upon the light. Next is what is reflection. When light falls on a highly polished surface, like a mirror, most of the light is sent back. Then this is the incident ray, and it strike on the mirror, and then it reflect back. That is called reflection of light. The bouncing back of the light in the same medium, that is called light. There are two laws basically. First is incident angle. This is the reflected angle. Both are equal, like I is equals to r. And second is incident ray, normal and reflected ray lie in the same plane. Next is images formed by plane mirror. The image is always erect, and the image formed same size as the object. The image at the same distance from the mirror as the object in front of it. The image is virtual. The image is literally inverted. You can see our left hand appears in the mirror as right, and right hand appears in the mirror as a left hand. So it is literally inverted. Next is spherical mirrors. Spherical mirror is a curved mirror which is a part of a hollow sphere. Spherical mirror are two types. First is concave mirror, and second is convex mirror. In concave mirror are those mirrors whose reflecting surface toward the center of curvature. That is called concave mirror, and whose reflecting surface away from the center of curvature is called convex mirror. And concave mirror is called converging mirror, and convex mirror is called diverging. It is called converging because it converges the ray at a point that is called focus. Next is the term used in a mirror, center of curvature. Center of curvature is the center of sphere of which mirror is a part C. It is denoted by C. Radius of curvature, the radius of the sphere of which the mirror is a part, that is called radius of curvature. It is denoted by R, capital R. Pole, it is the center of spherical mirror. It is a center of spherical mirror. Suppose this is the concave mirror, and this is called pole. Principal axis, the straight line passing through the center of curvature and the pole, that is called principal axis. This line is called principal axis. Principal focus, in a concave mirror, the rays are coming parallel to the principal axis. After reflection, it meets at a point that is called principal focus. In convex mirror, this is the convex mirror. The rays, this is the principal axis. The rays coming parallel to it diverge because this is the convex mirror, and the rays meets at a point, appears to meet, that is called principal focus. Focal length, the distance between pole and principal focus is called focal length. R is equals to 2f, and f is focal length. It is equal to divided by 2, radius of curvature divided by 2, that is equals to focal length. Focal length is equal to r by 2. Next is, it is denoted by, this is the picture showing a pole, this is the focus, this is the concave mirror, this is the pole, this point is called pole, and this is the focal, this is the principal focus, this is center of curvature, the xy line is principal axis, and the distance between focus and pole is called focal length. This is called focal length, and it is denoted by small f. Principal focus is denoted by capital F. Then f is equals to r by 2. Next is rules for image formation. How to draw images in case of mirrors. Next is first rule. If ray coming parallel to the principal axis, after refraction it passes through the focus. If ray coming parallel to the principal axis, it passes through the focus. Second rule is, if ray passing through the focus, if ray passing through the focus, if ray coming passing through the focus and after refraction it goes parallel. First rule is, if ray coming parallel to the principal axis, it passes through the focus. If ray passes through the focus after refraction, it goes parallel. This is the second rule, and this is the third rule. If ray passing through the center of curvature, it traces same path. If ray passing through the center of curvature, it goes back in the same path. It follows the same path. That is third rule. Next is how images appear when the object is placed at infinity. When object is placed at infinity, after refraction rays meets at focus, so image become highly diminished, point size, real and inverted. Next is when object placed beyond C, then image formed between C and F and it small in size and real and inverted and diminished. Next is when object at C and it, when object is placed at C and image is also formed at C, image is same size as the object and real or inverted. Real, same size, you can see this is object, this is the image, and same size at C, formed at C. Next is when the object is between C and F, the image is formed beyond C. It is enlarged, you can see, and this is in large size, object is small size, smaller size. This is the larger size where we place the object is placed between C and F, then large image is formed beyond C. When the object is at F, when object is at F, then image formed, when object is at F, then image formed at infinity. And first rule is, what is the first rule? First rule in which object is at infinity, image is formed at focus. When object is at focus, image is formed at infinity. Next is when object is placed between focus and pole. When object is placed between focus and pole, then image is formed behind the mirror. It is enlarged in size, virtual and erect. Next is these are all images formed by the concave mirror, and now we can see the image formed by convex mirror. Next is when object is placed at infinity. When object placed at infinity, image is formed behind the mirror at focus and highly diminished, erect and virtual. When object is between infinity and pole, when object is placed between infinity and pole, then image formed behind the mirror, it is diminished, virtual and erect. Use of concave mirror. Concave mirror are used in torchlight, searchlight, headlight of the vehicle to get parallel beam of light. These are used for shaving mirror to see the larger image of the face. They are used by dentists to see the larger image of the face. They are used by dentists to see the large images of teeth. Large concave mirror are used to concentrate sunlight to produce solar furnace, produce heat in the solar furnace. These are the uses of concave mirror. Now the uses of convex mirror. Convex mirror are used for rear view in the mirror in a vehicle. You can see in our cars there are use of convex mirror. In our car there are use of convex mirror. Convex mirror are give erect diminished images of object. They are also have a wider field view than plane mirror. Then sign conventions for a spherical mirror. In the sign convention, all distance measured from the pole. If we move right to the pole, from the pole right to the from the pole, then all distance kept positive. If we move left from the pole, all distance taken as a negative. And then if we move upward direction, all distance taken as a positive. If we move downward, all distance taken as a negative. This is the sign convention for a spherical mirror. Next is mirror formula. Mirror formula is equals to 1 upon V plus 1 upon U is equal to 1 upon F. V is the, this is the concave mirror. Here object is live and there is image formed. Then distance between object and mirror is called U, and distance between image and mirror is called V. Then 1 upon V plus 1 upon U is equal to 1 upon F. This is the formula to find the focal length if U or V are given. Next is magnification. Magnification is the ratio of height to the object to the height of the image to the height of an object. Magnification is equal to h dash upon h naught. If height of image is equal to h dash and height of object is h naught, the magnification is also related to the object distance and image distance. Then magnification m is equal to minus v upon u. Then this is another formula to calculate the magnification. Thank you for watching.